All right, in this video we're going to talk about the definition of the inverse of a function. All right, so basically what inverse functions are, just to give you like a basic definition, inverse functions are opposites of each other, right? So like if one function adds 5, the inverse of that would subtract 5, right? It does the opposite of what the original function does. All right, so that's just a basic understanding of inverse functions. They just do the opposite thing. Right, now the mathematical definition of an inverse function, let f be a one-to-one function. Right, so that's the first important thing. In order for a function to have an inverse, it has to be one-to-one. Right, and in a few minutes I'll explain why that is. Right, so let f be a one-to-one function with domain A and range B. Right, then the inverse function f inverse. Right, so another thing here. The notation for an inverse function is that f with that -1 exponent, right? It's not really f to the -1 power, but whatever the original function is, if the original function is called f, we use the same letter, f, for the inverse of that function, and then we put that -1 up there like it's an exponent, and that means the inverse of that function f, right? It doesn't mean f raised to the -1 power, which, if you remember the rules of exponents, f to the or something to the -1 means take the reciprocal and flip it over. That's not what this means. All right, so it's just one of those things you have to understand and get used to. When you see a function name with that exponent of -1, it doesn't mean take the reciprocal of the function. It means the inverse of the function. All right, so when you're reading this, don't read it as f -1. Read it as f inverse. All right, so its inverse function f inverse has domain B and range A. All right, so the original function, the domain is A, the range is B. Right? For the inverse function, it switches the domain and range. The domain is now B and the range is A. Right? That's what inverse functions do. They switch the domain and the range. They switch the inputs and the outputs, the x and the y values. Since they're opposites of each other, they basically just turn everything backwards. Right? So, and then the definition of the inverse function is f inverse of y equals x is the same thing as saying f of x equals y. All right? So basically what we're saying here, so for my original function, if I plug in some x value, it gives me some output y, right? If I take that output from the original function y and I plug that into the inverse function, it gives me back that number or whatever it is that I plugged into that function originally, right? Again, the inverses switch the inputs and outputs. Right here, x is the input and y is the output. On the inverse function, if I do the input of y, I get the output of x, right? It just kind of switches them around. All right, so that's the definition of an inverse function. And down here, there's a mapping diagram to kind of help us understand what's going on. So we have on the left side here the set A, which is the domain of the f function. On this side over here, we have the set B, which is the range of that f function. And x is going to be my input value into the f function. So if I take that number x, whatever that happens to be, and I plug it into the f function, well, it gives me some output value, y, which is equal to f of x. Right, so I plug x into the f function, it gives me the y value, y equals f of x. If I take this y value now and plug that into the inverse function, it takes me back to x, that original number that I plugged in, my original input to that first function. Right, so again, inverse functions undo each other. So let's say I plug 5 into my original function, and it gives me 10. Well, if I plug 10 into the inverse function, it takes me back to 5. Right, so there's almost like a loop that they're doing. Oh, one of them is always undoing what the other one does. Right, so my x here is equal to f inverse of y. Right, y becomes the input into my f inverse function, and that gives me the output of x over here. All right, so again, inverse functions, they do the opposites. They undo what the other one does. They kind of take you back to where you started from. If you do one after the other, it just takes you right back to where you started. Right. Also notice what we said up here with the domain and the range. For the f function, A is my domain and B is my range, right? These are my inputs to the f function. This over here would be my outputs. But for the inverse function, since the inverse function is going in this direction, right, it's going in the opposite direction of the f function, the set B over here becomes my domain, and the set A over here becomes my range. Because for the inverse function, f inverse, these are my input values and these are my output values, right? So that's why up here, it says that the domain and range are switched around. That's why. Right, the outputs of the original function become the inputs into the inverse function. All right, so that's some of the definition of an inverse function. But one other thing that we kind of skipped over here, f has to be a one-to-one function. In order for it to have an inverse, the function must be one-to-one. So let me show you up here on this diagram why that would be. All right, so let's say that this f function was not one-to-one. Right, so what does a one-to-one function mean? right? Or if you didn't watch the video I did on one-to-one functions, you should check that out. But a one-to-one function means for every x value, there's only one y value, right? That's what makes it a function. And for every y value, it only comes from one single x value. That's what makes it one-to-one. All right, so let's say this function was not one-to-one. Let's say we had another x value here. So let me call this one x1, and let me put another x value here called x2. All right, and let's say x2 also gets mapped over to that same y value. Right, so two different x values here going to the same y value. That means it's not a one-to-one function. Right, it's just not one-to-one. Okay, because again, the definition of one-to-one is each y value can only come from one single x value. If a y value comes from more than one x value, then it's not a one-to-one function. Right, so if f here is not a one-to-one function, right, it's still a function, right? For a function, I can have two different x's going to the same y, that's fine, but that's not a one-to-one function. All right, so then if I try to do the inverse of that f function, well, now I have the input over here, this y, and it's going to get mapped to actually two different functions, right? The y could go back to the x1 or it could go back to the x2. So if this one input value over here is actually going to two different outputs over there, then the inverse would not be a function, right? Because remember, the definition of a function is for each input, you can only have one single output, right? But now when I'm doing this inverse here, this input of y has two different outputs, the x1 and the x2, so that inverse relationship there is not technically a function, right? That's why we say that f has to be a one-to-one function in order for it to have an inverse, is because if it was not one-to-one, the inverse would actually not be a function. All right, so that's like a little technicality when you're dealing with inverse functions. You know, if the original function is not one-to-one, technically you don't have an inverse, but there is a way to get around that. Mathematicians are very clever, so there's a way to still create an inverse function even if the original function is not one-to-one. And what you do is like you limit the domain of the original function. So we say, well, for this function f, let me just take this part of the domain and let me ignore all those numbers there. And now since I only have this one input going to y, now I have an inverse because now it's one-to-one function if I ignore all this stuff up here. Right, and we'll get to that when we do some other problems on some other videos. But that's how you kind of work around that of it not being a one-to-one function. All right, so again, inverse of a function. It switches the x and y values. It switches the inputs and outputs, the domain and the range. You know, the input of the original function takes you to the output. The output of that original function becomes the input of the inverse, takes you back to the original number that you plugged in. All right, I'm going to pause the recording here and put up a couple examples dealing with inverse functions, and we'll do a little work with them. All right, so here's our first example that we're going to do. We're given just some function values for some function. So f of 1 is equal to 5, f of 3 is equal to 7, f of 8 is equal to negative 10. And what we're asked to find here is f inverse of 5, f inverse of 7, f inverse of negative 10. All right, so if we do like a little mapping diagram just to hopefully make this super clear to everybody. So my first input here, well, let me draw both of these. My first input is 1, and that gets mapped to a 5 over here, right? And that's the f function going in that direction from here to here, right? The input of 3 gets mapped to a 7. And the input of 8 gets mapped over here to a negative 10. All right, so that's what's going on with my original function, right? So my original function is going from this set to that set. All right, so my inverse function then goes the opposite way. So if I'm going in this direction now, that's going to be f inverse, right? Going from the right set to the left set. So f inverse of 5 is going to equal 1, right? F inverse of 7 is going to go back to 3, and f inverse of negative 10 goes back to 8. All right, so again, inverse functions, they just undo what the original function does. Right? If the original function takes 1 to 5, well then the inverse function takes 5 back to 1. Right? The original function takes 3 to 7, the inverse takes 7 back to 3. The original function takes 8 and turns it into 10. The inverse function turns it into negative 10. The inverse function takes negative 10 and turns it into 8. Right, so when you're doing these types of problems, just pay attention to the notation, right? These are all f of 1, f of 3, f of 8. These are all that f with a negative 1 there, so those are all f inverse. Right, so you have to recognize that inverse notation of that f negative 1 so that you know what you're being asked to do with a problem like this. right? But it's pretty simple. If you understand what an inverse function is doing, like you don't even have to draw this mapping diagram down here. I did that just to give you like a visual aid of understanding what's going on. But if you understand it, like, well, f of 1 equals 5, so f inverse of 5 is just going to take me back to 1, right? The input for the f function becomes the output for the inverse function, right? It switches the input and the output. The 1 and the 5 and the 1. The 3 and the 7, 7 and 3. 8 and negative 10, negative 10, 8. All right, that's what's going on with inverse functions. They kind of take you back to where you started from. All right, I'm going to pause this again and put up another example, slightly different, again, dealing with inverse functions. All right, so we just looked at an example where we did some work with inverses, just given some function values, f of this equals that, f of this other thing equals the other. Now we're going to look at similar things, finding the inverse values of a function or evaluating inverse functions, but given a table of values and then also given a graph, right? So a couple of different ways that functions can be represented to us, and just using those to find inverse values. All right, so here we have a table of values, x, and then the function h of x gives us the outputs of those values. And I'm asked to find h inverse of 8, h inverse of 12, and h inverse of 3. All right, so if this is x and h of x, remember the inverse function goes backwards. It takes the outputs from the h of x function and maps them to the inputs. All right, so if I want to find h inverse of 8, I don't look on this side for 8, I look on the output side for 8. Since I'm dealing with the inverse, I have to go backwards, right? So h inverse of 8, well, here's my output of 8, and that gives me 3. So h inverse of 8 is 3 because h of 3 equals 8, right? H of 3 equals 8, therefore h inverse of 8 equals 3. Again, inverses switch your input and output values, your x and your y, your domain and your range. They get just swapped around, right? It's kind of just doing things backwards, right? H inverse of 12, right? Well, I'm doing the inverse function, which means I look at my output values. Here's 12, and 12 comes from the input value of 4, so h inverse of 12 equals 4 because h of 4 equals 12. All right, again. Inverse functions, I'm just switching the input and the output, right? H inverse of 3, all right, be careful here, right? Because I have a 3 on the list. Don't say, well, h inverse of 3 equals 8. H of 3 equals 8, right? H inverse of 3, well, here's 3 on my outputs, and that comes from the input value of 6. So h inverse of 3 equals 6 because h of 6 equals 3. All right, so I hope that makes sense as far as what inverse functions are doing. Literally switching the input and the output, just doing the function backwards. That's what the inverse function is. All right. So those are those ones there for the table of values. For the graphing one, same idea, but obviously a little different because now we're given our function represented to us in a slightly different way. All right. So now we're given the graph of a function f, and we're asked to find f inverse of 5 and f inverse of 3. Right. Again, be careful. Read the notations carefully. Pay attention to the details. It doesn't say f of 5. If it said find f of 5, I would go to x equals 5 and then go up here and what's the y value when x equals 5. That's not what we're doing, right? We're asked to find f inverse of 5. Since I'm looking for the inverse function, I need to start. 5 is like my y coordinate up here. So I go to y equals 5, and I got to figure out, well, what's the x value that comes from y equals 5? And it comes from 7, right? F of 7 equals 5. Right? When I have x equals 7, I have a y of 5 on my graph of the f function. That means f inverse of 5 equals 7. Again, switching the x and y coordinates, that's what the inverse function does. All right, if I want to find f inverse of 3, again, inverse function, so I'm going backwards. I'm starting with a y coordinate of 3, which happens here, which looks like that's at x equals 4. So f inverse of 3 equals 4 because f of 4 equals 3. All right, so that's inverse functions, evaluating them a couple of different ways depending on how you're given the information, whether it's a table of values or a graph. But when you're evaluating an inverse function, the number you have in the parentheses now is the output from that original function or the y value from that original function, and you're looking for the input or you're looking for the x coordinate, right? Inverse functions, you're doing things kind of backwards as what you do with regular functions. All right, now I'm going to do some more videos involving inverse functions, including, if you're just given a function definition, f of x equals 3x minus 2, how do you find the inverse of that? Right, so make sure you check out those videos as well, because that's an important thing to be able to do, is actually find the inverse of a function.